Hi everybody. So in this video we're going to be introducing section 2.1 where we will be talking about areas between curves. So let's say that we're talking about an interval a, b. And on this interval we have two integrable functions f and g such that on ab f of x is greater than or equal to g of x. So we can draw like a generic picture of what's going on. So if we have some function f and another function looks like this, let's say g, well, we see that f is not bigger than or equal to g on for every single x, but we can pick an interval on which f is bigger than or equal to g. So let's say we're going to study these two functions on a to b, which is right here. And we want to find the area in between these two curves. So this yellow area here. Okay. So we know how to find the area underneath f, bounded below by the x-axis and on the left and right by the vertical lines a and b. So we know how to find this area here. All the way down to the x-axis. Okay. And we also know how to find this area here. Underneath the curve, the red curve g of x, bounded below by the x-axis, and the vertical lines a and b. So it seems that the yellow area, so yellow, is equal to the green minus the blue. So green minus blue, minus purple, I'm sorry. I get confused with my colors. And this actually is true. So how do we write this mathematically? Well, we say that the area between the curves, in this case, is given by the integral from a to b of f of x dx, because that's precisely what that green area is. And we have to subtract off the purple area, which is the integral from a to b of g of x dx. But by properties of the definite integral, this is the same thing as the integral from a to b of f of x minus g of x dx. So that's nice and pretty useful for when f is bigger than or equal to g. But what happens if that's not the case? So let's say that we have something that kind of looks like this. So we have a function f. We have so we have a function that looks like this, f, and then we have a function that looks like this, g. Okay, and let's say that we want to find this area now. From, let's say that this now is a, and over here is b. Well, f is not bigger than or equal to g on the entire interval, but we can split it up into two intervals on which one function is bigger than the other. So where these functions cross, let's say that this point is c. So then we could find this first yellow area by taking the integral from a to c. So which function is bigger here? Well, it's f of x minus g of x dx. And that'll give us the yellow area. But then we have to add to that the second yellow area, which would be the integral now from c to b. And in this, from c to b, in this interval, g is the bigger function. So we would do g of x minus f of x dx. And that would give us that yellow area that we need. So lastly, one more area to consider is if we had something that looked like this. So we have this blue function f, and we have this red function g. And let's say we want to find this area here. Okay? So this is the x-axis, and this is the y-axis. So the tools that we just discussed above don't really work right away. I mean, I'm sure that you could finagle a way around this and figure out how to do it in the same way that we just did the previous two. But one way that we can possibly think about doing is by looking at this graph, these two functions, not as functions of x, but as functions of y. So what does that mean exactly? Well, what that means is that we can rotate this graph. So now it looks, we could rotate it left. So now the y-axis is the horizontal and the x-axis is the vertical. So here we have that this function is going from some points on the y-axis now, c, up to d. And we actually know how to compute this area, right? We can use the tools that we used before. So we can do the integral. So now we would say, let's say from c to d of the bigger function here, which would be f. But the key here is that f is no longer in terms of x, it's in terms of y. So we're rewriting f as a function of y, and it's the bigger function here. And we're subtracting off g, which is the smaller function when we write it in terms of y. So we can rewrite these functions that are given to us in terms of x, we can rewrite them in terms of y, and it's essentially like just rotating the graph and doing the exact same thing that we did in the previous two problems. So in the next video, we're going to go through some examples of how to rewrite these functions in terms of y instead of in terms of x, and hopefully that it'll concretize this concept. So thank you for watching, and I hope this helped, and happy reading.